Hello everyone, welcome to another stream. Right, so it's supposed to be live. So, quick recap. Last stream, we were working on this lovely brick material. And it's all done procedurally in shader code at runtime. So we have this materials.h, and per pixel it runs this brick shade. So you get the material gets passed in from the mesh, and it switches on the material, and then it runs this brick material code. So it procedurally generates a 3D texture, or the pixels for the 3D texture, right? In a sense, right? So yeah, we got this far last time. It's okay. We got many more improvements to make, that's for sure. You know, on a sphere it looks a bit weird, and it's a bit flat as well. There's no depth, so it'd be nice to make things like just add lots of improvements to this today. So I got some ideas. Now there's a few things, right? So I guess I'll read over this. So we were trying to add like a noise to this, and you've seen this sort of like this. It's a bit noisy here. I'm trying to make it look a little bit rougher. And we've been using simplex noise, and it's quite expensive. So we could probably use a more simple noise like value noise, and that one should be a lot more efficient, but it might not yield as good results. So we'll play around with it. We also want to try and modify the surface normal to give the illusion of depth. Right? We want to make it. We don't want to make the wall look flat, right? When you look at it from the side on. We want to probably chamfer the edges such that you can offer the ability to chamfer it basically. If you're not sure what that is, so you've got like a block. If you chamfer the edges, you sort of cut the edges off. Yeah, you like cut the edges off. We probably want to use a noise texture on the wall with high frequency bumps when close, a bit like what we've done here already, but with a different noise function. We probably want to use a different noise function again for low frequency, darker patches of brick. No, you should notice that all the bricks you want them to be kind of different colors as well, not just the same color. Maybe change the brightness of them. Per brick, there'll be a different set. And then we probably want to make the edges uneven. We kind of tried to do that, but we probably do a bit better. And we probably want to sort out the ambient occlusion as well. When we're adding sort of a fake depth, the ambient occlusion really helps sell that as well. So these are things to play around with today. Should be pretty good. And hopefully we can get this thing wrapped up. That'd be pretty nice. Well, we want to test out as well is like, so if we bring up the profiler, we're looking about 1.12 milliseconds for the scene shade. So if we were to simply return this earlier and just return, I don't know, like a gray. Then what's the performance is it? Right, 0.29. So we have about 0.3 milliseconds of overhead, if you will, on this particular resolution. So the cost of this, at the moment is about 1 millisecond, right? So that is a bit too much. So I was thinking, okay. So if we get rid of, let's undo something we've done and we'll redo it again. So this fractal Brownian motion of simplex noise is just probably too expensive, but we can still do an FBM of value noise, and that'll be far cheaper. So we just explore this for a minute. So effectively, what fractal Brownian motion does is it takes many different uh, frequencies of the same noise function and combines them all together. So, and it combines them all at different, right? You could take the very high frequency information, the very small changes, um, very often changes, so that it shows up as very the value changes a lot over time, high frequency, right? You can have those ones show up to be more opaque, if you will, whereas the lower frequency would be less opaque and combine that result smoothly. Or you can go the other way around, right, where the sort of larger low frequency information is more opaque and the higher frequency stuff is less. So FBM allows you to sort of do that with these sorts of parameters here. So at the end of last stream, I sort of did a quick bit of Google and I found another noise. So this is the simplex noise. As you can tell, if you do like 4 octaves of this, that's a lot of stuff happening, right, per pixel. But still, GPUs are so fast that you do kind of, it doesn't really cost that much, right? It costs like, it's still, you can still kind of use it in some cases. But we could probably try this other one. This one here. So it's a bunch of lerping, that's for sure. But basically just something like this. And that is more efficient than all of this. Especially with these normalizers. With permutes, a couple of mods. Anyways. So 3D point. The noise value. FBM. So try this one. It's more efficient. Hey there, Cyan. How you doing? Substance designer at home. Not quite, because it runs in a runtime. And it's not got a node graph as well. So we try out the so we swap out the simplex for noise. Yeah, that's halved. That's twice as, it's half the cost there. So, but it obviously changed the look there. It didn't really contribute at all. Interesting, but anyways, so what we would like to do is, right, which one's the easiest ones to do? So we probably want to, hang on a minute, I've got to start with a prayer. I forgot last time as well. Right, Father in heaven, we bless your holy name. Thank you, Lord, for this day. Thank you for providing us all the food that we have and the peace in our land. Not everyone has peace in the land today, in this day and age. I just pray for every soul with me today that we learn something, that we have productive time. And I pray that each and every one who's around me, Lord, if they've not got peace in their life, that we declare peace in their life. Peace, be still in the mighty name of Jesus. We pray for every country that's at war right now, that they come to peace and know that everything gets settled, and ultimately your will is done, Lord, in this kingdom. And we pray for we pray this session today goes well, productive. Find out the right things to do. Don't do things for a waste of time. But come to a good understanding on what to do, what to find the right path to success, and help me understand more about my future tasks whilst doing this task, as in the future material work that we'll be doing, and anyways, thank you, Lord. We bless your holy name. In Jesus' name we pray. Amen. There we go. So, what would be the best one to do? So we could start like doing doing the bumps around the edges, and what the darker brick colors is probably gonna be a good one, because that's not going to mess up by doing a future one. So we kind of want like a higher frequency, lower frequency, darker patches. Yeah, that one. That'd be a real good one. So let's start off with this noise thing. So it's going to bring us back like a few different values. Is it? No, that's not good. Yeah. Okay, so right, here we go. So I think we do want this. I think it gives you a value between. Hang on a minute, I just gotta. It gives you a value around. We're not to 1.2 then. Right, I guess it just depends on the octaves and stuff, because it's. Right, so what's the comprise of? So if it's just, okay, it's taking a bunch of fractional values um and then this will get you 0 to 1s, and a whole bunch of lerps. Right, and then the accumulatedness of it. I see. I see. I can see what's going on now. Okay, so let's see what it looks like if we take the. So I'm not really a fan of that AO thing at the moment. We'll sort that out in a bit. Cool. So the. Yeah, so I guess we can apply some kind of like. If we take the noise. Let's just pass in brick chord F. Okay, so mm, this is what the noise looks like. That kind of looks all right. Although you expect it to change on every brick X, Y. Yes, we're looking at changing the color. So I think you can take this and you can apply that on top of the color somehow. So color maybe multiply equal this. But then right, but then we're still the problem is we sort of see the lines. Oh yeah, so you only really want that applied if you're on uh coloring actual brick, not necessarily the paint. Sorry, not necessarily the border. Yeah, that's right. Cool. So that sort of works, although what I would like to say is we should probably squish it down by yeah. So that's adding some kind of like uh variation of the shade of the brick over the and then most will be 0.5. So we sort of like up it. Then this makes it a bit higher frequency, right? And sort of getting these patches show up. I think just having it the way it was is good enough. Now, yeah, cool. So the next thing is like, what about the sort of like brickboard F thing? So if we move this around, we could. So it's going to move every axis evenly because it'd be a scalar value. Now I wonder if you can take the noise function and do with it. It's a bit too much there. Um, yeah, so it needs to be higher frequency. You make it times it by 16 or something. But then I don't know if that's a bit too wobbly. Particularly nice. You could take. You could combine. Just do an inline FBM kind of thing. Combine a couple of frequencies. They're not particularly straight anymore, but then ours, isn't it? Yeah, so I wonder if we can do um see how much different simplex is. That's gonna be expensive anyway. Yeah, it goes into the negatives, I think. That's another thing about simplex. Too expensive anyway. So it's 0.8. Yeah, 0.6. Well, right, we'll find a way to make this one work. So, or we could try PCG and all that. Maybe. Yes, we did this before, right? You can then flatten it. Oh, you could do and turn that into a float. Divide by vec3 e32 max. Why is that not going to work? I'll record F. Alright. Yeah, you kind of want like a flawed version of it. Then if you multiplied it by, I don't know, 1,000. Oh, wait. Happened before in it. Hang on. Alright, did that recompile? Nope. Oh, they're at. Crap. Busy printing stuff here. Oh, of course we can't stop printing because we're... Right, let's figure this one out. So this would be... But that compiles. Right, so... Oh, I'm going to brick order. Of course. Cool. So this is kind of interesting. It's very fuzzy. So it's super high. Of course, it would be super high frequency, wouldn't it? I think. This would change it, wouldn't it? Nice. Yes, it's very blocky. So I wonder... if we can do... Interesting. I wonder if you could take multiple of these and combine them. Because it is very cheap, isn't it? Can I comment that out? Ooh, yeah, so 0.49 it said up there, now it says 5.3. Okay, so if we added another layer of that. Yeah, it's all about just being careful of the performance as well. So we did like a 16 and 32. Yeah, that's the thing though, isn't it? It's like it's too blocky. It's too much of a... It's like a white noise, isn't it? So that's a big no-no. Yeah, we definitely want like a gradient noise. But then I wonder... Right. Line these boys up. So the issue is this is not three-dimensional. So we could take this hash 1. So take P. Yeah, so maybe we can manually do hash. So something like that. Hang on. Oh, interesting. So that is too noisy. And then it does the interpolation. Ah, I see now. Yeah, so that's too noisy. It interpolates between IF. I see. The integer part, the fractional part. Now, okay. Okay. So we could probably do the same thing, but with noise. But then that's going to be 3 times as expensive, but you get a slightly different result maybe. Oh crap. Because if they're all the same, it's obviously going to be, then you change it to, but then depending on the dimension, they will look different, isn't it, basically? It's probably not the right thing to do. Yeah, so maybe what we had before, we can multiply them all together. Ah, what was it? So they usually get multiply added with something in an FBM type thing. I think that's the approach. So yeah, then FPM will sort of offset this by something else. Yeah. So multiply by, you know, do you want to, how much do you want to keep it basically? And then add. We could do 0.9 for now, let's say. Okay, so basically choose how much I'm going to keep it. So 16 will be the more higher frequency one. You go higher frequency, B. There's more lower. How much of that do you want to keep, basically? 2 times by 0, you get rid of it, and so on. Make it get weaker. So 16, 32, 64. Let's try that. Bit too spiky, I think. So maybe 8, 16, 32. Right, so maybe that's fine. Wait, 64 milliseconds right here already. Right, it's a crash. I think maybe yeah, so you can see some off in the distance there. I think the it does come across a bit spiky or whatever. Yeah, 'cause sometimes the FBM, what it will do is offset it as well, isn't it? It will multiply with some it has like a lacunarity where it moves. Oh, it just moves the point, yeah, via multiply, yeah. So, and that's what we were doing. Yep, that's fine. So, so maybe I'm thinking the higher frequency layer could probably go. Yeah, so I think here actually, we probably connect, or maybe we can just do with one layer. Let's see how that looks. Yeah, actually, you know what? Maybe just having something basic like that is fine. Then what we're missing is like a bit of depth, right? The depth will sell it, right? You just want the bricks just to be like a bit uneven, and then the having some depth would sell it on top of that. I think that will actually be fine. It's just how much of that do you want to take is the question. Yeah, I think that's what you would like. And the question is in terms of that's too wobbly, right? Yeah, something like a 4. Now, you just keep the... Yeah, okay. Let's just keep it simple. That's good. Very nice. Cool. So, right, that's good. We've got the unevenness now. It's very nice. So what else? We've done the color. You know, notice how the different sort of shades. We've just dropped the... We've just multiplied the color to bring it down. To make it darker. So there's different shades, basically. Did you see that in brickwork all the time? Yeah, this is all configurable. Oh, that's something we should make it configurable. So what we'd like to do is, yeah, this should probably be made configurable. Like, how much wobbliness do you want? I think is the idea, right? Oh. Yeah, I guess you could probably put up to 1. Yeah, it's way too high. But that probably needs to be some kind of slider. So you could probably say wobbliness or whatever you'll call it. So on in the encoder system, the brick encoder file, we can add another one called wobbliness or whatever. Um, Evenness or edge, brick edge, unevenness. Is that the way you spell it? Uneven. It's an extra N, isn't it? Yep, good. English. So you want a value that is packed into maybe how many bits we got? So we've got one word here. Now we're on a new word. We probably round it up to the nearest 8 bits. That'd be handy, right? So that'd be a 5. And you just do a 1, a 0 to 1 value, your brick unevenness. So float brick edge. So that's here just to multiply by that. Oh wait, there you go. So maybe that's the max. We can probably go a bit higher. What was it again? Anyway, yeah, we'll try that. Maybe 0.6 will be the highest wobbliness. We'll go to the graphics side of things. We've got the brick material. We really need to get this from a file. But yeah, so the idea is you can have a bunch of different parameters that go into the same brick shader, and you can produce all these different types of brick materials from a single shader. That's all we're doing. So brick edge. So 1 unevenness, right? 0 to 1. Cool. So that'd be proper cool. Right, just let it crash. Right, what failed? Too many. Oh, it needs to be a set. That's why. Lovely. Cool. That's all configurable now. Bit too wobbly, but there we go, it works. Now, the next thing. So we've got the wobbliness, we've got the... Right, so we've done this low frequency darker patches. We've done the edges being slightly uneven, yep. We've not done this bumps. And we could chamfer the edges. Yeah, we've not done the normal as well. But we've been using the value noise. So we're kind of getting into a good place. I'm not sure about how we're going to do the rest of them though. It might require a bit of thinking. So we kind of want to have a way. So you know, the chamfered edges can't really work without a different surface normal being able to be provided back out. That is true. So we need to probably add, right, and that's probably going to come from a depth value in some way, because what we kind of want is the ability to see the depth, like the depthness of the brick, right? You kind of want to see the the sort of under edge, right? You want to see that, and I think you would achieve that with normals, or you could fake it with just basically ambient occlusion, and then like baked ambient occlusion, and then you probably like round off the edges as well, maybe, I don't know, in ways, but that would require a lot of, if you could output the right normal, then so yeah, there's a few different ways we can achieve that. But yeah, so the chamfered edge, we'll save that one till later. The surface normal, we've got to think about that one too. The bumps on the bricks, so more higher frequency sort of information to make them look a bit more textured, if you will, and maybe have like, holes in them or whatever, some kind of texture on top. That could probably be done without doing any of the depth stuff. That's true. So maybe we'll do that one next. But then again, there's this sort of ambient occlusion thing. So you know what? Let's quickly double check our code, because for the PBR code, I did kind of rush the AO in there. So we do kind of want to double check. Yeah, has anyone got any good resources, by the way, for PBR? And how the AO would stick in, because I'm just gonna, if not, just use AI and just see if I can find resources that way. But I want to try and see if there's some non-AI resources, but the internet's usually terrible for this stuff. Scene, what is it? It's in materials.h. Yeah, so the bit I'm looking for is like this sort of thing when we do the BDRF stuff. Like, well, the ambient irradiance, reflected radiance, this is just taking it from the pre-computed diffuser radiance of the sky map and the specular, basically. Then I've got the light radiance of both the sun and the moon, and then I just combine it all out. Now I'm wondering where the AO goes. I've just stuck it here, but I think that's probably wrong, so I need to figure that one out. And plus I want to kind of double check my whole thing anyway. Right, so let's see if we can do. So we would like to see GLSL PBR BRDF with a single directional light, if you will, and cook torrents. What we did a cook torrents and Oronaya diffuse, didn't we? Give that one a go. Hang on a minute. We put my material shade before. Yeah, we've got to reorganize some of this stuff. It's a bit all over the place, but it works. Okay. Anyway, so we've got the Oronaya diffuse and then cook torrents specular. And Oronaya. No. There we go. Use. And then what else was it we had? Using diffuse specular gloss workflow, if you will. Let's see if it understands that English. I want to double check it. So I think we use these ones. It doesn't really matter, because that's all cooked torrents anyway. Then, right, so you cook torrents. Let's have a little look. Yeah, this is way too simple, I think. So the shadowing function. So n.h, n.v, n.l, n.h, n.v, n.l. L dot, so light dot half vector, eh? When we do a light dot half vector. Right, that comes out at the end. It's not in the cooked torrents. Yeah, so you basically just taking a product of Fresnel, yep, all those, and then 4 times n dot v, n dot l. This one's different. 4 times n dot. I don't think this is the bit I had the problem with. My thing I had a problem was the diffuse. This is a bit too simplified, I think, this version here. Yeah, diffuse specular times light color. So let's have a look how that works. Yeah, for now is specular colors goes right in there. Yep. Do, 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 do. And then out color, here we're BRDF, so it's the diffuse plus specular times the light color, the radiance, n dot L. Yeah, cool. So I think that looks fine. I'm wondering, where does baked AO? This is my question, really. So ambient diffuse. Right, so it has to be. Okay. Your ambient light is here. Now, on the metals, though. Right, so if you have specular, right, as in it's metal, you're not going to want to contribute any diffuse anyway, right? You have 0 diffuse on a metal, so the AO is not even going to be applied. Okay. Interesting. Yeah, I want to try and find that out. Does AO get applied to... I think that's a no from my understanding. Right, beta AO should not be applied to specular component of metals. It primarily affects ambient diffuse line. Since pure metals have 0 diffuse contribution. Right. Okay. Yeah. Okay. There. Albedo is black. Yep, applying the standard. I see. Simulates occlusion of indirect hemisphere light. Metals do not have a diffuse component. It's only the reflected light. Yep. I see. Specular occlusion. Occluding a metal's reflection is a different phenomenon. Multiplying AO to the metal's specular map is physically incorrect because it implies the material itself is less reflective in crevices, which isn't true. The environment is simply less visible. Right. Use specular occlusion or screen space reflections to handle darkening of reflections in tight metal crevices. Okay. More specular occlusion. Let's look at that one. But yeah, the brick that we're building right now is purely, obviously, it's not metal, right? So that's interesting. I'm not heard about this one before. So AO end of V roughness. Ah, right. Surface roughness, view an angle to estimate how much of the reflection should be blocked by the surrounding geometry. If you have a metal pipe and inside might have high AO dark, right? However, without specular occlusion, the inside of the pipe still reflects the bright skybox perfectly. Right. The approximation, right. Use a visibility factor V based on the AO and the roughness. So that's interesting. So indirect specular, okay. Just take one. All right. I think what I might do is chuck that in so we don't forget about it. And we can always, you know, we might do some kind of screen space reflections in the future anyway. So I wonder, would you use specular occlusion with SSR? But the roll shifts slightly to prevent light leaking from different sources. Yeah, so the ones which are not visible, you would probably use right, I see. Yeah, so you'd for the image-based light and setup, you'll use that, but not for the SSR. Cool. Makes sense. Bring this boy in. Alright, what I'd like to do. Alright, let's put it here with these shading guys. Specular occlusion. So N dot V AO and a roughness. Let's just do roughness. Followed by AO. Oh, N dot V. So that gets applied in the calculate surface color on the reflected radiance here. So yeah, it's all multiply, so you just do this. Cool, so it's n dot v, shading, roughness, followed by the AO. Right, so at least we've got that sorted out. I'm happy with that. Right, so going back to the whole brick stuff, because we did take a bit of a detour there. I'm not really working on metals today, but I was just hoping that, you know. Alright, so let's go back to goodbye to you. Okay, so we want to try and figure out like what's the best way that we can achieve some kind of depth without it being too expensive. So you do have parallax occlusion mapping, but that can be, you got to basically ray march the ray and keep sampling a height map. Well, a height map is not a texture, so we have to keep redoing the texture and only providing the height, which you might be able to save some computation, but not all. And since we're doing some procedural um, noise stuff as well, it can probably get quite expensive. So we probably want to not do parallax occlusion mapping as much as possible, right? So question becomes, what else what other solutions do we have? Yeah, so we could do that high frequency bumps and stuff like that. That could probably be done with AO still. A lot of that maybe. And yeah, so I guess let's do that because that could provide some kind. Yeah, let's do that quickly. Let's just play around and get a nice. You know what as well? I've just noticed some of these follow the same sort of patterns next to each other, which is not very nice. What we would want is possibly on the brick. It would be better if the neighbors didn't know. So when we say brick coord times 4, then it's obviously kind of related to where the brick coordinate is, right? So in a way, you want to add some kind of like thing such that it's different for each brick, kind of. So what we could do is take the brick coordinate floored version, maybe, or you could apply YZX to itself. I don't know. Is that complaining for some reason? It probably didn't like the new function I've added. Hmm. Oh, of course, I ain't got brick chord yet. See a brick chord F. Right. Yeah, I think that's worked out better. Obviously, it's quite excessively wobbly, and that's fine because this is like the max wobbliness, and it's just parameters we can provide. Maybe I can bring the wobbliness down, but if we get rid of that, you'll see here how they're different now. But if we remove that, they sort of all look kind of the same together. Now they're kind of against each other a bit, which is cool. Right. Bit too excessively wobbly. So let's go graphics VK. Let's make it half wobbliness. Oh, edge unevenness. Come on. There we go. So now we've got some unevenness, not completely uneven. There we go. Those sort of look similar. Okay. I guess you can have near at 0, you're going to have them basically be the same. Kind of. Anyways. Let's roll with that. For now. Cool. So we want to add another layer of noise on top. Get the performance out. Don't do this to me, please. Crashed. Sometimes crashes on screen resize. There will come a time where it'll be bug squishing time. Bug squishing time will come when I get fed up enough. Right. So we're looking about 0.7 milliseconds for this size of screen for this particular. Right. So what are we trying to? We're trying to add some sort of like high frequency information on the I guess the whole texture. Yeah, let's do that. So this case would be, let's just play around with the color. We'll do color equal noise 3D. We'll take in the brick coordinate floating point, and we'll simply times it by, I don't know, 256. It might be a bit too high frequency, but let's just try. And we shall, I guess, dress it up in a vector 3. Yep, super high frequency. And we want it to obviously be less. Let's try 32. Right, so this is maybe what we want. I don't know. But so if we apply that on top of the color now, that's what you get. So we could probably times by 0.5 plus 0.5. And then it's sort of squished and moved up into the upper values. You know, so we can see some bricks off in the background here. It kind of looks okay. You know, we could times it by we could squish it down even more. Right, and then move it up even higher, and then it's got even less of an effect. But I am sort of seeing, I think let's make it more apparent again. I think the biggest problem is you're seeing the blockiness of it. So this is where you could have the layers where where we do the classic, the thing we were trying to do earlier, right, where we do the blending of these layers, and you could probably have different contribution of them. You know, you can add a 64 layer and then add, maybe 128 is too high. Now, let's do reduce 16, 32, 64. Interesting. Right, that kind of looks not too bad. Then if we, I guess we could try. So you could apply different amounts of each. So if we drop the you know, I think having them even is actually not too bad. Maybe we don't need the highest one. I don't think we need the highest layer. You know what, it could be helpful. Yeah, so we take that. And now what we're looking at doing is times 0.3, or divide by 3 if you will, because that takes an average. Then we want to shift it up. We want to squish it down, so we range between 0 and 1. Squish it down to 0, between 0 and 0.5, then move it up between 0.5 and 1. Bit too much there, unfortunately, so we need to do a bit more squish. Hang on a minute, can I... Why don't I just get rid of this? What's the brightness? Yeah. We could blend it on top. Additive blend, maybe. No, don't don't do that. Bad idea. Right, so okay, maybe more squish. Yeah, I wonder, so these noise values, hang on a minute, noise 3D. Let's see what the value is. It's between 0 and... Right, I didn't see a value go less than 0.3. Oh, I did a bit there. Oh yeah, 0.1 right there, we saw it. I didn't see it going higher than 0.7 though. That's interesting. Oh, 0.8, I saw it. Okay, so possible. So what does that mean? If you add 3, yeah, that's same as divide though, innit? Then yeah, okay. Although yeah, it's looking better. That's definitely looking better. I wonder if we could more squish. Yeah, I'm kind of liking the look of that. Maybe though, it's still looking a little bit blocky in some cases. If we added another, right, higher frequency doesn't help. I guess it's just a case of if you added a lower. So I reckon you just start dampening out some of these basically. maybe, but I think that's better than it was. We can stick with that. So that's about 0.9 milliseconds. We get rid of this. Right, so it added 0.2 milliseconds. Doing that. Okay, that's fair enough. Yeah, I think we're trying to stick around the budget of 1. Because if we get rid of all of this, it was around 0.3 the overhead, right? So the PBR already takes 0.3 milliseconds. So we've only added like 0.5 milliseconds at the moment, which is cool. Right, so that's good. Now, oh yeah, yeah, it's fine. Cool. Next one would be we want to add. Right, we have been delaying this one a lot, but I think we've basically got there now. So we've done the cheaper noise. We've not done modifying the surface normal or yeah, chamfering the edge. But we've done these 3 now to do with these different bumps, quote unquote bumps, and the patches and stuff like that. But we have just been changing the color, mind you. And maybe that should have been done with the AO. Can we see what that does if we make it AO? What's the difference? Okay, ready? So keep an eye on maybe here. Over here. Keep an eye on here. As we go, ready, and go. No difference. Did make it 1, so right, no difference because it didn't compile. Oh, vector 3, that's why. Hang on. Right, here we go, ready? Keep an eye. Oh. Yes, it makes no difference doing it as AO or, which is strange. Right, let's just do it as AO. Hmm. Confused. Cool. Let's move then over to the depth side of things. Right, so, one of the things that makes materials look better is if they have a depth, right? When you look at a cube and you just see a brick texture, you look at it from the side and it looks flat. It really is jarring and it oh crashed. It really doesn't make it feel like doesn't make it very nice, does it, basically, and if it looks flat. So we see to the side of these spheres, and you can clearly tell on the side they just look very flat. What we kind of want is we kind of would like the brick to like pop out, if you will, in a way, and maybe to see the underside of it, see the sides here in a way, right? So we've got a few different ways we can do this. And we do kind of want to change the normal as well. Ultimately, you want to have some part of the brick where the normal goes down. Like, what you could do is take the brick coordinate and then like change the normal based on that. But then like if your camera, you got to be careful to make sure that the view vector, if you will, is also pointing in the right way. And then that way you could get You could fake the bottom edge by probably just changing the normal, maybe. And the normal is in world space, so we've got to do some magic. Well, not magic, but do some maths to sort of make that work right for different viewing angles. That's one way. Just simply based on the brick, get the sort of, these ones up here, we only want to be seeing these edges, but not the edges on the right and top, right? So you could do that, and that could sort of sell it. You probably also want to have some kind of like, the AO as well must be really, a lot more AO around certain areas of the border than others, maybe. But it's kind of baked though, isn't it? And it's not really going to be based on any light directions and stuff like that, because we're not doing material shading per light. You sort of sample the material, you've got the properties, and then you feed that into all the different lights. So there's that. We have talked about parallax occlusion mapping, but that's going to be too expensive because you're basically running this same code over and over again. Not nice. We shouldn't really need this. That's not going to add performance, is it? Surely. Because that was not... Yeah, it wasn't used. It was compiled out anyway. Cool. Yeah, I think that's probably the best solution. Just faking it, basically. Faking it based on the view direction vector and what thing you're sampling. But then you kind of want to do it based on distance to edge, if you will. Might work. But then... Yeah, I think you could do it. So let's just try this by darkening for now and see how that looks. So you want to basically work out your sort of like, let's just call it V. So given the sort of brick coordinate, so the brick coordinate is integer, but there's a floating point part of it. So you take the floating point part of it, so the fractional. So fract this guy. So we did this here, right? Kind of based on the border. So I think maybe you're really looking for this sort of border value here, to be honest. And you want to kind of know if I'm inside it. Yeah, so I think you want to take... We want to call this like... So... 5... Border distance. Something like that. So fract... Yeah, so border dist. Now you got border dims. So you maybe want to have like... Let's just write another value in here called edge dim. Edge dims equals 0.1 divided by brick dims. That makes it a vector 3, so it's even. Goes from normalized to unnormalized. Then so based on this border distance, so is it really a border distance? So we did, if it's greater than border going to here, yeah. So yeah, it is a distance. So take away border dims. And then you want to basically say so this edge with the edge dimensions, you want to know, I guess it's a smooth step. So you've got, I always get these wrong. Edge 1, edge 2, x. Cool. So edge 1 is going to be 0. Then the second edge is going to be edge dims. Right, so if the value goes after edge dims, v will be set to 1. And if it's in between 0 and edge dims, it will be smooth between 0 and 1. Right? So the x value will be this. And then we can basically, so because it's going to be 1, yeah, something like that, cool. So do we want to be a smooth step though, or just a hard step? I think I want it to be a hard step actually. So step, but what is step then? It's better just doing a Tenero operator, isn't it? Yeah, you kind of want to do like step, and the edge will be edge dims. And now you find, so you're going to go vector 3, and you want to find probably the max, and it'd be 0, 1 basically. The max element, I'll call it. Right, so what we're doing is just say color times equal v. Oh, come on. So this would be a vector 3. Cool. Now this is not what I wanted, but because something something has changed. So the next thing is to border distance, take away the border dims. Yeah, edge. Your edge is edge dims. Let's do 0 0.0. Aha. Not very nice. So why then is, so if one of them passes, they all pass. Yeah, I think this is a 3D texture as well, and the issue is you're going to get... Yeah, that's going to be problematic if you sort of extend it out one side, towards the camera basically. It's going to be closer. It's not really a good one. You kind of need to get the plane that you're on as well. Kind of true. You see, I wonder at this point if you need to go into local space and do it that way, like on the plane. But then again, you kind of want it to work across all of them. But yeah, no matter if it's square or not, you see. So right, so why is that? Hmm. I wonder why the ones at the top aren't coming in. Very bizarre. Hmm. Yeah. If all are greater than border, so we take away the border. Is this causing us problems? It shouldn't be. No, exactly. So take the max element. Yeah, max of x, y, x, y, z. No biggie. So if any of them pass, basically you get a 1. Ah. Then you want it the other way around. If any of them don't pass, you get a 0. Yeah, I think that's the problem. In. Cool. But right, so we finally did it. Now it just looks very cartoony. So what you kind of want these to be is like uh so if it's 0, you kind of want it to... Yeah, so maybe maybe smooth step is the thing to do. Let's try that out. Why are you complaining? Why you no work? Alright, stop that. Oh, okay, you gotta do your vec expl... Right, so that sort of looks okay, but I would do it the wrong way around. You want it to be darker. Yeah, I think this is cool. Now, here's the thing. That's great. Kind of. Right, so we get rid of this. It really makes the whole image feel darker, but it's actually not. It is really just the borders. Cool. So as we're seeing, we're getting it's lighter at the top and then darker at the bottom, which is kind of what you want. Then but now here's the thing, we want to do it based on the viewing angle, which is interesting. Because then that will give you the illusion that there is kind of depth, right? You can't, in a way, yeah. Like, for instance, we can't be seeing the bottom of these here. We should just be seeing, wait, we should just be seeing darkness here. And not even, and this one here probably, but not this one here. It should just be light, right? So we have the viewing angle being passed in the shading. We do have the view direction. So and we do have the surface position in world space. So yeah, it's interesting. So the thing is we cannot like right now we've just been using the texture space coordinate, and I don't think it would be fair or proper if we were to tie the texture space coordinate to the direction uh, in any way, probably, because we could probably color. We could put the 3D texture coordinate on the mesh in different ways and really create like a wall that's filled with a brick that it follows all the way around, which would look kind of nice. But yeah, so if we have like, rather than being a 3D volume where the texture coordinate just smoothly goes between the 3D volume as a 3D position, we can make it such that the X and the Y value specifically follow around a path, and the depth, the Z, goes along the thickness of the wall. So we could we could texture map it that way. So we want to make sure that we don't tie 3D position of the texture coordinate to the 3D-ness of the world, if you will, maybe. The thing is like, how can we take the view direction vector? So that would be from the surface to the camera, that direction, and say, hey, drop this edge. Well, we could move that into the space of the. We move that into the space. They do those TBN vectors, rather, the tangent by tangent and sorry, the tangent by tangent and normal. normal being the surface normal. So you could do that sort of thing. And then you'd have to do the classical encode of the, tangent and bitangent stuff. In your vertices and that. So we could do that. And then that allows you to bring some of those world space parameters into the texture space. But could we not bring it to texture space anyway? Without that. Um, no, you'd have to encode that TBN as part of the and then bring it into texture space. Right, I think we could just play around for a minute without doing that because it's a bit. Yes, all right. So let's tie it to the world position for a minute. The shading dot view direction. And that's it. Yeah. So effectively, yeah, I think let's just hard code it for a minute just to see how it looks because we can try and do it properly, but if it doesn't look good, maybe we've got to do a different solution. So we want to know if it's pointing up. So where is it? The UV thing. Brick coord shading UV divided by. Yeah, so if we did, if they're kind of going same way, no. Yes, if the sign of, if the sign of this dot xy is equal to the sign of shading.uv. Let's just hard code it for now. All equals that or equal. Then multiply v by that. Right, it's called equal, I think. Dot xy. Turn into a float. Hmm. Hang on a minute. XY is Because the XZ is the floor plane. XY be across and up. You can't look and see if one of them are the same way. I think. Some elements. Oh, there's no equal anymore. Oh yeah, equal. Back to some elements. Yeah, I think here we just want to do printing because clearly we don't know what's going on. So with these values, shading dot view direction world space XY and here we go. Someone else. So right, what's going on here? So your UV is it ends in a 2. The UV as we go to the right, the X increases. As we go up, the Y decreases. Right, so it's the Y is the wrong way around for some reason. Why is that? I don't know. But here we go. So Vec. How bizarre. Why did the UV go the wrong way around? How's the UV being done? Clean shade. Hmm. Just the position in local space. Oh, the view direction is the wrong way around. No, it's the right way around. Hang on a minute. Oh, yeah. Good. Yeah, so this needs to be flipped the other way. We flip them the other way. Yep, they both got the same signs. Lovely. Cool, that's what we're looking for. So if you flip that the other way around, now we're looking for at least one sign. So oh right, I see. So we need to get the edges. The edges need to be, you need to know what edge of the brick you're at. If you're at, yeah, I think you want to know, maybe, yeah, I think if you take brick chord, you need to figure out which edge you're at, basically. So that's what you want instead. Now, based on, you want to know if you basically want to get like a normal. Like, what's your... Yeah, so given the center position of the... Okay, call it N. So given the center position of the brick, so that would be the floored version of brick chord. So brick chord plus 0.5. Then you want to go towards a brick chord F, then normalize. Yeah. So I'll get you N, and you're doing the sine of N, I think. Then like that. Right. Okay. The problem is this is being applied for every single... You only want to apply this on the... If V is less than 1. Alright, so we're trying to say if the directions are... Yeah, so maybe it's the wrong way around. We flip the... Yeah, so we're trying to get rid of the board. This nice border we generated. We just don't want it to be applied if... Yeah, I think it's quite simple, right? Probably a Boolean expression. Hmm. Alright. Something like this. Um... Okay. Is it the other way around? Yes, so... Yes, if this one here we can't really see the... You don't really want to see the edges if you will. Is that right? You want to see the edges here, and you want to see it all the way along here, and all the way along here, but not up on these two here, right? So um, right, let's test this one out. Let's print out in. Okay, so we get like a negative on the x, negative, negative, positive. Cool. Negative. Yeah. So that value is looking really good. Let's chuck in here the other one. Let's put it at 2. Okay, so when we're on this one, we've got 1, which is that normal one, and the view direction. So let's not negate it. Right, so here it's obviously going to get shaded, that's fine. But as soon as we switch over to here, one's going to be positive, but one's going to be negative. Yeah, so we kind of want to make it where it's any of them. Just make it any. If any of them are equal, we do that. Ooh, that's looking better, isn't it? So the problem is, though, it's still getting the top edge, which is not right. So maybe what you're looking for is a... Yeah, there's a trick where you get the normal of the of a box of an AABB. You want that basically, isn't it, on a 2D one? So half dims take as Tn vec. Something like that. So ST, so the N is dep inside the box. T2, UST2. Oh, then N times sine of RD. So that's along... Yes, I think we want to change the code so when we have something that's more down, it will give you the vector pointing down. When it's more to right, it gives you a vector pointing right. Yeah, that's what you want. So right, so for that one, V is going to be
I'd just like to interject for a moment. What you're
Ah,
referring
hey
to
there.
as Balenciaga is in
Melbourne
fact
Eka, welcome
GNU
sir. Thank
slash
you so much for the
Balenciaga,
sub, appreciate
or as
you.
I've recently taken to calling it, GNU plus Balenciaga.
So this already gives you a value between 0 and 1 based on how close you are to the edge. Right, so it's 1 the closer you are to the edge. So hmm. Min element. Yes, I think you're gonna put max element. Yes, I think you want to, based on this, pick the value which is closest. Mm, yeah, this doesn't give us what we want. We need a slightly different one. Yeah, I think the easiest thing just do is just if n dot, if abs n dot x is less than abs n dot y, then clear out and make it something like sine of n dot y, so n dot, yep, else. Okay, so let's just try that out. Now what we're trying to say is if, oh no. Right, so looking at 0 point, yeah, it's looking at 1. So left would be -1, and -1 on the y, good, good, good. It kind of cuts off here a bit though, you can see the diagonal line. Not bad. Right. Has a bit of a cut though, which kind of sucks. Maybe it's okay. Anyway, so now what's the logic to get this to work? So it kind of looks, I don't know why this one fails. Right. So for the side which has the same, so for the component which has 1 in it, that's the one we really want to test the sign, if you will, I think. You just check and see, does it point? It's just a dot product at that point, isn't it? Basically, it's a dot. If dot this vector and that vector, do they go in the same direction? That's it. Yeah, so this is kind of the look you want, right? It's not the best. You got to sort out these edges, but this is one way of faking it, right? And giving the illusion. As you can see in the distance, it's sort of doing it, right? It's sort of falling my eye. Um, as I move the camera, it probably will. But yeah, there's some. Hmm. Yeah, so it's as if they're going the same. It's a bit bizarre. So we got rid of that. That definitely wouldn't help it, would it? Right, kind of did the same thing. So it's the dot. The dot product is just the nature of how it does it. I guess. Hmm. Don't know if that's. Right, it's updating now. Cool, cool, cool. Okay. Yeah, I wonder what's given that sort of. So one. Interesting. So here, or is it? It's where these pixels are black here. Supposedly, it's going more to the X. Right, that's because the N. I see, right. Hmm. Okay. This is because the reason why we get this sort of artifact here is because the space that it's doing it in is like a normalized space of the brick, as if it's doing it as a square, but it's actually a rectangle. And that's why we're getting this sort of artifact. So it's because we've divided it by the brick dims, the shading UV. So it's not proportionally the same on every dimension. So I wonder if you take the shading UV from Maybe you can't really do it. So you kind of want like a rounded down version of this, going to where we are. Yeah, shading UV dot XY. Then you would like to take brick coordinate, but then plus 0.5, then multiply it back up to UV space, and then well, that didn't work. Why did that want to work? Hmm. So plus 0.5, put it in the middle. Hmm. I wonder if I got the camera angle right, so I'm doing it across the XY plane. I definitely am. I think so. We could test that out by trying this. Hang on. Yeah, so X across, Y up. Yeah, so yeah, X would be red, Y would be up. So that's cool. That is right. X, Y. So you've rounded down the brick, so put into brick space basically. Then we've gone to the center of the brick, moved it back out of brick space into UV space. Then you're saying go towards that UV coordinate that we're shading from the center of the brick. Shouldn't be anything wrong with that. It's bizarre. So we could take these two coordinates and print them out. That is a possibility. Oh, hang on a minute. There's a brick offset, that's why. There's offsets here. This is causing some of the problems. Hey there, not sure how you doing. I think this might be causing the problem. All helps. Yeah, so going back into UV space is not necessarily an easy thing to do. So what we could do instead is actually reapply just reapply this. .xy. Right, so getting something here. You're kind of seeing a diamond shape now. This is very interesting. I don't know why we're seeing that, but okay, so I think it goes right. Okay, so maybe it's a divide. Can't be a divide, can it? Well, apparently it is. I think that's right. I know what you're looking for. Hmm. Not really. Still a bit off. Stuck on some shade nonsense, right? I know what you mean. That's cool. What sort of stuff are you working on? Give me the details. Not kind of what I was looking for, unfortunately. Oof. Yeah, so this is one approach we could do. Seems alright. I wonder if there's a better way we can achieve it though. We could instead number which edge it's on as an int. Um, so yeah, it is kind of a three-dimensional brick as well. Yeah, we're just going to try and do XY for now, won't we? The other way of trying would be full test code here, basically. So we could take the so your -1 to 1, you could and turn it into integers. It's kind of the same thing. It all depends on the normal, having the right sort of normal thing, but I wonder if you could pre-multiply that by brick dims .xy. That's why it didn't work. The crazy thing about it. Because that gets you over to shading UV space. No. Right, let's print this out again. So 1 is n. So then it's to the right as soon as it goes here. Ready? Yeah, that's because the if statement, isn't it? I think. Maybe you want it to do. Right, let's just say n equals sine n. That might be part of the problem. So for this one here, we're getting obviously a 1, -1 or whatever it is, right? Now, you're saying color both this right wall and the bottom wall. That's what you're saying. So the dot product isn't going to do it because that's not going to work. So you're saying if yeah, I think we can get this. So it's if the sine, we kind of wrote this earlier though, equal, but we didn't times it by the brick dims before earlier. So if they're equal, the sines, I think you got to negate it the other way. Then or maybe some elements if that's greater than 1. I gotta wrap in another vector 2 again. It basically looks the same here. Greater than 0. Yeah, so this is where it does it a little bit. It's kind of right, it's just got this here and this here, which it shouldn't be doing. So this is because, so 1 will be -1, -1. We don't want the left. Yeah, it's over by a bit, isn't it? Yes, interesting. We want the sort of in between of that, if you will, right? We would like. So this only does this portion here. This one does. Yeah, kind of too much. So if your direction vector is going this way for the camera, you want a vector that's going a y that's down. No. Or an x that's positive. But you don't want an x which is negative. But you kind of do, right? Yeah, an x that's more negative than positive. But then we did that before. And we had those problems with the corners looking a bit off. Yeah, we had that if statement when it's that if abs n.x. But maybe we didn't have the multiply in as we do now. Let's try that. Then we're basically saying n equal vec to 0 sine. We just do this, right? So you do and then the thing we had before was the dot, but then I think we ran out of the hot code reload sometimes breaks after a while. No, it's the same. Okay, so this seems to be doing the same thing. Anyway. Yeah, of course. Okay, so let's have a play. So this should be -1, right, until looking at this one here. So -1 on the y. Oh. It's not. It's constantly setting the x for some reason. Um. Yeah, it's pre-signed, that's why. Yeah, okay, so bizarre. What is normalizing? Is that a problem? Right, let's move this up here. Right, it's in UV space. I see. So because the center position's here and we've taken it back into UV space, it's treating it as a clear diagonal across here, right? That makes a lot of sense. Of when the X, so right, I see. So if we it was doing in brick space, then obviously has its problems. Okay, I think I see. Yes, this is the kind of best we've had it. It's just not quite right. It's a little bit off for some reason. And I don't know if it's because of all these alterations here that we've done. Problem still kind of persists. Let's take a look at the value. So the one field N. Right, this is the point where the X becomes greater than the Y. If it's in brick space, I wonder. Hmm. Hmm. So you're seeing the cut, it going directly diagonal from here to here. But why isn't it going a bit bizarre? Um, equals not going to cut it because it floats, right? So that's not the problem. Change it the other way, does it just meant, well, no, swapping those around won't do anything either. Hmm. Right, let's take a look at some of these values. So on the far left here, so it's essentially right, you've got the center position of the brick. So this is in brick space, so 0 is the bottom left, 1 is the brick. So you're essentially getting, we should be getting -5 to +5, right? So far left here on the N is 0.44. But we put it here on the border. No, it doesn't still get there. Yeah, you would say that's probably 0.5, maybe, because the border's taken away from the brick. Right, that might be it then. So the border's taken away from the brick unevenly. That's the border has taken away from the brick unevenly, meaning that we must apply the difference to this in some way. I don't know which way around it goes though. Wrong way. It was takeaway. Times 0.5. No. Well, that's not right either. Because that border dims is in brick space. There is edge dims as well. But that can't be doing it, can it? I don't think that's helping. It does feel like that is the problem, but I don't know why. So you got 0.4 on the top. Here on the Y. On G1Y. Oh, I lost that. And on the bottom be -4, right? Cool, cool. About 4.3. 4.4. I wonder if we can debug draw the position. There is a world space position, right? So it's UV surface pause. So we could draw draw 3D sphere. Surface pause. Yeah. Not be easy to do that either. So if we took away the border for a minute, how would that look? The next thing to do in it. Say if the border dims are 0. How will that look? Now you take away your evenness. You are getting the clear cuts along the... Right, that's looking like you're getting what you want there mostly. So if we add the unevenness back in, and then the border. Right, so we change the unevenness back to 0. Still not right, is it? Yeah, something to do with that border. Something to do with that border, eh? Yeah, realistically, it's the border. So, uh, it's just how it looks with the unevenness applied, I guess, but yeah, so we do that, we can clearly see that it stops kind of at the right place. It's because we've made it different on each. The border dim is different on for each dimension of the brick. It's causing problems. And that's why we tried to modify it a bit. But it doesn't do it justice. But also it kind of has a bit of another problem as well, where you kind of want this to keep filling. And so in those cases, what sorts of values do you get? So you get 1. Yeah, it's interesting. Yeah, you kind of want to have it cut off here-ish. Not have this bit here. And you kind of want to have that keep going. Yeah. Right, so I think I have to think about this off stream, but at least we made some progress. So I'm doing another stream tomorrow at 2 p.m. Friday, GMT. Gotta have a think about this one. But I think this is the route to go, in a way. Maybe there's another way we can do it. But if we basically just shade it and give the illusion, that should be good enough. And then I guess we have to probably shade. We probably want to make sure that we apply around the border here as well, some kind of AO. You probably want to stay on the border, that border distance or whatever. One of these sorts of things. So you're going from pretty fun. Oh, is that the wrong way around? It's the slight wrong way around, so it's one take. We do max element? Probably not. No, 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 no. One take. I can get some AO around the brick. Although you kind of want, again, you probably want the... But that's really giving the illusion away that it is 3D at least. I had some depth to it. Especially in the background there. That's looking really nice. Just, yeah, this shading's not too good. You probably wonder what happens. Yeah, you might want that in the AO. And maybe a square or something. Caps lock. Bit too much the square, I think. And then if you increase the distance of your border, I don't know, maybe you put a bit too high. Okay, just smoothly adds a bit more of a this things to play around with. Yeah, that bug that was causing that is it's to do with this normal thing that we sort of solve. Right, so I think there's some more ways that we can figure out how to sort of like pick an edge. You know, we want like these two edges basically, but completely those two edges and not kind of like taken off at the diagonal, you know? So we should be able to work out that tomorrow. And then the bricks will basically look like they have a bit of uh, depth to them, right? You don't really want to make them look. Yeah, there's stuff to. We should really look at it on like a as a side on angle as well, but maybe it's not too bad. Yeah, the reason why these ones don't work is because we're trying to do it on the sort of 2D plane, and this is on a different plane. So we need to figure out that problem as well. Once we get it looking good, and we can check it from a side on angle as well, we try and we have to make it work across 3 different dimensions. So right now we're just hard coding it across X and Y. So we'll probably have to do maybe that TBN matrix thing, bring it into the local space, and then that should work. Awesome. Oh, quite a thing to figure out. But what's great after we've done one of these, we can quite easily take this one and turn it into like, you know, a stone wall or something like that, maybe. Something to think about. But yeah, right. There's a stream scheduled down below, guys. If you wanna see when we're next on tomorrow, 2 p.m. GMT +1. Sorry, +0. And there's Discord if you wanna hang out in the meantime. And yeah, if you there's also a VOD channel on YouTube as well, where you can catch the streams on the VOD. I'm hoping this is the right YouTube link. Yeah, that's the one. Right, I'll catch you all tomorrow, hopefully, if not Sunday. And yeah.